Hello everyone, it's a pleasure meeting you all in my mathematics class. This is my second class in partial differential equations. Let me solve the first problem where you are given z is equal to f1 of y plus 2x plus f2 of y minus 3x. We are required to find what is the PDE, partial differential equation of the given function z is equal to f1 y plus 2x plus f2 y minus 3x. Given z is equal to f1 of y plus 2x plus f2 of y minus 3x. Let me differentiating with respect to ax. So what is that we will get here? Dou z by dou x, which is nothing but our p. And if you differentiate with respect to x and then you differentiate with respect to x, what is inside the bracket? So what is that you will get? As a whole, if you differentiate, it is f1 dash into 2 minus f2 dash into 3. That is nothing but 2 f1 dashed minus 3 f2 dashed. So if you differentiate this with respect to x, you will get this. Similarly, if you differentiate with respect to y, you get dou z by dou y, which is equal to q, which is nothing but if you differentiate this with respect to y, as a whole, if you differentiate f1 dash and you differentiate y with respect to itself means 1, here also 1. So what is that you will get here now? So this is nothing but f1 dashed into 1 plus f2 dashed into 1. This is equal to f1 dashed plus f2 dashed. Call this as your 2. Now differentiate this 1. Differentiate p with respect to x. Differentiate this p with respect to x. That is, you are getting the second derivative, second derivative of this z. So what is that you will get here? Dou squared z by dou x squared, which is pqr, which is equal to, you differentiate with this with respect to x means it is 2f f1 double dash, f1 double dash, and you differentiate what is inside the bracket. If you differentiate, this is 0 and differentiation of 2x is 2, so this is 2. So if you do the other way similarly, you will get it as 9 f2 double dash, which is equal to 4 f1 double dash plus 9 f2 double dash. Call this as 3. And now differentiate p with respect to y. Differentiate this p with respect to y, so we will get it as dou squared z by dou x dou y, which is notation. These are all notations, conventionally understood notations. P means dou z by dou x, q means dou z by dou y, r means this, s means dou squared z by dou x dou y. So like this. So this is equal to, so if you differentiate this with respect to y, so it is 2 f1 double dash minus 3 f2 double dash. Because if you differentiate this f1, what is your f1? f1 is nothing but your this thing. Y plus 2x is the function inside, y plus 2x. So if you differentiate it, you will get it as second immediate differentiation is, you have to go for the immediate differentiation and differentiate what is inside the bracket with respect to y. With respect to y it is 1, with respect to y it is also 1. So this will be nothing but 2 f1 double dash minus 3 f2 double dash. So I will write it as 2 f1 double dash minus 3 f2 double dash. You call this as your 4. Then differentiate, differentiate q with respect to y. That is, let us take the second derivative of this dou z by dou y, which is nothing but what? Dou squared z by dou y squared, which is conventionally written as what? This thing t. If you differentiate this is again is what? f1 double dash plus f2 double dash. So write me it is f1 double dash plus f2 double dash. This is your 4. Use 3, 4 and 5 to eliminate dou squared, see, p, eliminate your f1 double dash, see, f1 double dash and f2 double dash. See, we use these three equations to get rid of this f1 double dash and f2 double dash. See, here you have got here f1 double dash, here f1 double dash, f2 double dash, f1 double dash, f2 double dash, f1 double dash, f2 double dash. So we can get rid of this f1 dash and f2 double dash. Once we get rid of this f1 double dash and f2 double dash, you see that we will get the partial differential equation for this given z is equal to so much. So, see, use 3, 4 to eliminate f1 double dash and f2 double dash, which will give the required PDE of 1. PDE of, say I'll call it as 1. PDE of 1. How do you get rid of that? So this is nothing but you can write this as 4, 9R. 4, 9R, 2 minus 3, yes, 1, 1t. So if this determinant is found, the value of this determinant, so this is the partial differential equation. This, if you evaluate this determinant, you see that will be the partial differential equation of this z. Now this, so this implies 4 into, see, 4 into minus 3t minus s minus 9 into 2t minus s plus r into 2 plus 3 is 5. It is 2 plus 3 is 5 is equal to 0. So if I can find the value of this, that will be nothing but your partial differential equation of the z. So this is nothing but what? Minus 12t minus 4s minus 18t plus 9s plus 5r is equal to 0. Plus 5r is equal to 0. So what is that you get here now? So this gives, it is 5r. Then s means this is s and this is s. So plus 5s minus 30t is equal to 0. So this implies r plus s minus 60 is equal to 0. That is, what is r? R is dou squared z by dou x squared. S is plus dou squared z by dou x dou y minus 6 into dou squared z by dou y squared is equal to 0. So this is the required equation. So what is the required equation? So this is therefore PD of 1 is dou squared z by dou x squared plus dou squared y by dou squared z by dou x dou y minus 6 into dou squared z by dou y squared is equal to 0. So this is the answer for the problem z is equal to so much whose partial difference. So I have not done anything. I am finding what is my p, what is my q, what is p, dou z by dou x, dou z by dou y, or is the second derivative of z with respect to x, then I find z, that is nothing but the second derivative of z with respect to x and then with respect to y, and then t, which is nothing but the second derivative of z with respect to y, and I take only these three equations to eliminate this f1 dash and f2 double dash. If once that is eliminated, the resulting terms that you, this equation that you get will give you the differential equation. So that is what I have done. This is how the problem is done. Okay, let me pause on to the next problem. The next problem is, see, this is my lecture 2 in partial differential equations. See how this is. So this is over. This I have done here. So this is over. Now you are given that find the partial differential equations of all the planes which are at a constant distance from the origin. That means you have got like this, and you have got a plane, and this plane is at a constant distance from the origin. See, this is the origin, this is x, y, z, this is our plane S. So this plane S is at a constant distance from the origin, and we have to find the partial differential equation of that. Now we know that right here, we know that the equation of the plane at a constant distance of A from the origin is Lx plus My plus Nz is equal to A. That means this is a perpendicular distance. The perpendicular is the shortest distance, that is the distance from the origin to the plane. That I am taking it as A. This is my A. So wherever this is going, you see that the distance between this O and this plane is A. So this is where Lmn or the direction cosines of the plane. Lmn or DCs, direction DCs of the plane. It is the direction. DC means direction cosines. They are nothing but the direction cosines of the place, and we know that L square plus M square plus N square is equal to 1. So this is a property of the direction cosines. L is equal to, you must know that it is cos alpha, cos beta, cos gamma, and if you use that, you see that this will be the property. L square plus N square. L is the direction cosine of the line of the plane here. The direction cosine of the plane, and L square plus M square plus N square is equal to 1. So we have got these two relations now. So this is our relation 1 and this is our relation 2. This is the equation of the plane. This is the equation of the plane which is at a constant distance A from the origin, and that the from this where L, M, N are the direction cosines of the plane, and we know that by the property of the direction cosines, L square plus M square plus N square is equal to 1. Now I'll write here, see. Now you must know that we must get rid of this constant. These are all constants, L, M, N. If you can get rid of these constants, then you see that you are able to get the differential, partial differential equation of this plane. What is that? To find, see, to find the PD of 1, partial differential equation of 1. Eliminate L, M and N to get the PD. The PD of, I will call it as 1. See, I will call it as 1. PD of 1. So if you can eliminate this L, M, N from this equation of the plane, you are arriving at what is your partial differential equation. Now let me start doing this. See, Here you have got here. See, from this you can write, see, from this, see, so this implies n squared is equal to 1 minus n squared plus m squared. Let me keep it like this. Now, Lx plus my plus nz is equal to a. Differentiating with respect to x. Differentiating with respect to x, what is it you get here? Differentiate with this with respect to x, and you must know that z is a function of x and y. Here what is that we take? Z is a function of x and y. Now if you differentiate this, differentiation of this with respect to x is L, plus differentiation of my with respect to x is 0 because y is independent of x, plus n into differentiation of this is dou z by dou x is equal to differentiation of this constant, because it is a constant distance from the origin to the plane. Therefore this is a is a constant, therefore the differentiation of a constant is 0, and whereas this dou z by dou x, because z is a function of x. So this simply tells you that L plus np is equal to 0 because dou z by dou x is equal to p. So similarly, what is that you will get? Differentiating with respect to y. Say differentiation of this x with respect to y is 0 because they are independent variables. Whereas this is m plus n into z is a function of y also. So dou z by dou y is equal to 0, which implies m plus nq is equal to 0 because dou z by dou y is equal to q. This is a conventional notation, so we are writing like this. Now what is it you are having? L square is equal to n squared p squared, m squared is equal to n squared q squared. So I use this. See, L is equal to minus np. So L squared is equal to n squared p squared, m squared is equal to n squared p squared. Therefore, what does 2 become? So 2 will become as what? Here this is n squared p squared plus n squared q squared plus n squared is equal to 1. This simply tells you that n squared into 1 plus p squared plus q squared is equal to 1. This implies n squared is equal to 1 divided by 1 plus p squared plus q squared, which implies n is equal to 1 by square root of 1 plus p squared plus q squared. So this is what we get. Now you see that I am able to get the value of n. Now what I am going to do is I am going to use the values of this L. See, L we have got the value of n, we have got the value of m, and we have got the value of n here. Using these three and the equation 1, we eliminate the constants. I repeat this. See, from this I can get L in terms of n, m in terms of n, and n value has been obtained. Are you able to understand? See, L here, I am able to get the value of L here. Here the L value is obtained, here m value is obtained, and I know the value of n. Here this L is known in terms of n and p, and m is known in terms of n and q, and n value is known to us. Now we will substitute these values in 1 to get the differential equation. Are you able to understand? Therefore, I will write it here. See, let us use, I will call it like this. See, this is 1. You can write this. See, here I will call, see, this we will write here. Here let me call this 2, 3, 4. See, let us use the values 3 and 4 in 1. See, using 3, 4 in 1, we get, let us use this 3 and 4 in 1. So what is that you will get? Here L is nothing but what? Your L is, so from this you can write this. L is equal to NP, M is equal to NQ. See, minus NP. See, I have got here. Here L is equal to minus NP. Here from this, not this, I will write it here. I'll call this. See, L is equal to minus NP, M is equal to minus NQ. So I am able to get the value of this, but N value is obtained as it. So using, we call this as your 3. Call this as your 3. L is equal to minus NP and M is equal to minus NQ. And I know the value of N. Now substituting 3 and 4 in 1, we get, what is that you get here now? So you get minus NP of X, because L value is minus NP, plus minus NQ of Y, plus N is equal to 1. So N is equal to A. What is that I do? I take these values, N is equal to minus NP I know, L is equal to minus NQ I know. I substitute these values in here in 1 to get the partial differential equation. So minus NP of X plus minus NQ of Y plus N is equal to A. This implies, see, it is minus NP. See, I will write this as, see, minus, I can write it in any way if I want. So this is nothing but N into minus Px minus Qy plus Z is equal to A. So this implies minus Px minus Qy plus Z is equal to A by N. So this A by N is nothing but what? A by square root of 1 plus P square plus Q square. Therefore, what is that you get? Therefore, Px minus Qy plus Z is equal to, this is 1, N is equal to how much? N is equal to 1 by N. So, N is equal to 1. So, P minus Px minus Qy plus Z is equal to A by N. But N value I have written here, say using 4. This I. So 1 divided by this. So this implies this will go to the top. This is this 1 by something. So you see that this will go to the top, giving you A into 1 minus 1 plus P square plus Q square root of that. Therefore, what is that you get here? Therefore, Z is equal to Px plus Qy plus A into square root of 1 plus P square plus Q square, where P is equal to dou Z by dou X, Q is equal to Z by. So this is our partial differential equation. This is the required PDE of the plane. Lx plus My plus Nz is equal to A. So this is how we do the problem. I will do more problems in the coming days. Do not fail to subscribe to my channel.